Chapter 3, Example 1. Mr. Ortman's first period algebra class received the following scores on a recent test. Create a dot plot of the data. So here we have 18 test scores, and we just want to plot them on a number line. That's all a dot plot is. It's a very simple plot, pretty easy to do, especially with a relatively small data set. So we make a number line. My lowest value is 58, my biggest value is 96. So I'm going to go from about 50 to 104. They'll give me plenty of space. And I'm going to plot each point. My first data point is 93. I'm going to plot that on the graph. I don't have to put these in order. It will all work out as I plot them. Then I'm going to plot 58, 63, 72, 78, 77. That finishes off the first row. And I'll just keep doing this for all 18 data points. So we'll just go ahead and plot the rest up here. And finally, 82. And there you go, that's the dot plot. Now we could space this a little differently. We could count by 2s or by 5s or something and stack them on top of each other more. But that's just your basic dot plot. So stem and leaf plot preserves the data values. We can look at a stem and leaf plot and at least recover part of the original data. If they're big numbers, you may have rounded so you won't get the entire number, but you can get a good feel for what the original data value was. In this case, we'll be able to see it really clearly. 58 is the smallest number, 96 is the largest. If we counted by tens, that would only give us 4 stems, and we like having a few more. So let's split that in half. We'll kind of count by 5s. So we'd have 50 to 54, 55 to 59, and so on. When I make this stem and leaf plot, my stems are going to be in 5s. So what I mean is, I'm going to have a 5 and a 5. So the first 5 represents 50 to 54. The second 5 represents 55 to 59. The first 6 is 60 to 64, and so on. So I'm going to fill in stems here. I'm going to have 2 5s, 2 6s, 2 7s, and so on. There we go. So I have all my stems filled out. So the stem was the tens digits. The leaf is going to be the ones. In the 50s, I have a 58, and that's it. I don't have anything between 50 and 54, so that first stem won't have any leaves following it. The second stem, which is 54 to 59, will have the 58 in there, so its leaf will be an 8. In the 60s, for 60 to 64, I have a 61 and a 63, so my leaf will be a 1 and a 3. I always want to put these in order. So from smallest to greatest. So from 65 to 69, I won't have any values. From 70 to 74, I have that 72 in there, so I'll have a 2 for the stem. For 75 to 79, I'll have 76, 76, 77, 78, so I'll have a 6, 6, 7, and 8. And they'll keep doing that for the 80s and the 90s. Now, as you can tell from our stem and leaf plot here, it was important in the leaves to make sure they're spaced evenly. I don't have, in the 82s, I don't have the 2 scrunched close together and then the 3, so everything lines up. All the first leaves line up in the same column. The second leaves all line up in the same column. The third in the same columns, and so on. So your spacing has to be consistent here. Let's make a box plot of this data. Now, this is the most complex one we'll have to graph. It's not too difficult, especially when we use technology in the future. However, there is one thing that we commonly do not check, and we'll explore that here. It's called the upper and lower fences, and they're very important for determining outliers. The first thing you need to do is put all of the data in order. We have to find some summaries and such here. So to do that, we need all of our numbers in order. We go through 58 is my lowest value, then 61, and so on. 96 is the largest value we have. Okay, now that they're in order, I need to find what are called the 5 number summaries. I need to find the minimum value, the Q1, the medium, the Q3, and the maximum. Q1 is the first quartile, Q3 is the third quartile. The minimum and maximum are fairly easy to find here. 58 is my smallest number. 96 is the largest. So I'll fill those in. The median is the middle number. Now you can cross off at the ends, cross off 58, 96, 61, 93, cross them off till you find what's in the middle. And on a small set, that's not so bad, but if you have a large amount of data, that's going to take you a while. And there's actually a formula for finding it out because it's the midpoint. We're looking at a number line, the midpoint is where our median will be. So think of these as a position. 58 is the first position, 61 is the second, so on. 96 is the 18th position. So if we can find the position that's in the middle, we'll be able to locate the median. We do this as n plus 1 over 2, which will be 18 plus 1 over 2, which gives us 9.5. N is the number of data points we have. We're going to see that a lot this year. Make sure you understand what n is. We get the 9.5 position. Well, that's in the middle. 82, the first 82 is my 9th number. The second 82 is my 10th number. Since we have 9.5, it means the median has to be right in between those, in the middle. In this case, that's going to clearly be 82. But if it's not, you just take the average. You add the two middle numbers together and divide by 2. My median is right in between, so that's going to be 82. Okay, Q1 and Q3 are very, very similar to the median. But for Q1, I only look at that lower half, everything to the left of my median. And for the Q3, I look at everything to the right of the median. So I have 58, 61, 63, 72, 76, 76, 77, 78, 82. I want to find the middle value there. We can do the same thing. There are 9 numbers in that lower half. So n plus 1 over 2, which is going to be 9 plus 1 over 2, or 5. The fifth value is my Q1. So the fifth value there is that first 76. We're going to repeat this on the upper portion. So everything to the right of the median, again, this position should be at the exact same place from the median because you split it evenly in half. So if there are 9 values below the median, there has to be 9 values above the median. So the fifth value above the median is 89. And so my Q1 is 76. My Q3 is 89. These are called the 5 number summaries. We'll look at these quite a bit, and they're the basics for building a box plot. Now, before we proceed, we need to find one more statistic, the IQR, which is the interquartile range. Range, as we know, is the difference from the maximum to the minimum. The IQR is the difference from the third quartile and the first quartile. So IQR is Q3 minus Q1. So in this case, we have 89 minus 76, which gives us an IQR of 13. So 50% of all of our data points will be within 13 values of them. And now that we know the IQR, we can calculate what we call the upper and lower fences. We use these for determining outliers. The lower fence is Q1 minus 1.5 times the IQR. So in our example here, it is 76 minus 1.5 times 13, our IQR, which is 56.5. The upper fence will be Q3 plus 1.5 times the IQR. For this example, it's 89 plus 1.5 times 13, which is 108.5. Now the lower and upper fences are important because if our minimum or maximum values are outside of the fences, we consider them an outlier. If they're inside the fence, then we really don't even worry about the fence, but I'll show you on the graph how we do this. So now we're ready to plot the box plot. We start with a number line. We're going to use that same 50 to 104 that we used earlier. So I'm going to start by plotting my lower and upper fences. My lower fence was 56.5. My upper fence was 108.5, which actually comes off this number line a little bit. We'll plot it over there on the right. And now I'm going to plot my 5 number summaries. My minimum, 58, 76. The median, 82. My Q3, 89. And finally the maximum, 96. And you see that all of the values fall in between our fences. That's good, there's no outliers here. Next, I put a box around Q1 and Q3. I make a rectangle around these values. Then we're going to put a line through the median, a vertical line through the median. That is the box portion of our box plot. Sometimes this is called a box and whisker plot. So I'm going to hit my minimum and my maximum before the fences. So I'm going to put a small vertical line through each of these because I'm going to erase these dots in a minute. That just shows the end. So I'm going to put a vertical line through 58, vertical line through 96. And now I'm going to make a whisker, a horizontal line from my Q1 to my minimum. And I'm going to do the same thing on the upper portion from my Q3 to my maximum. We clean that up a little bit. We get rid of the dots, and I don't need the fences in this case. So that leaves us with a completed box plot. Describe the distribution of test scores. So we have several graphs we can use to help us describe this. The most useful are probably going to be that stem plot that we created and the box plot because they both give us useful information. Whenever you're describing a distribution of univariate data, of data with one variable, we're going to cuss. We want to discuss the center, anything unusual, the shape, and the spread. We know several of these things from the box plot. We know the center. We know there weren't any unusual values because there were no outliers. We know where most of the data falls between because of the IQR. And the shape we can tell more easily from a stem plot. There we want to talk about, is it unimodal, bimodal, multimodal? Is it symmetric? In this case, our stem and leaf plot, if you go back and look at that, the center was around the 80s or so, and it went as low as 58. It was skewed a little bit to the left. It looks like it has a little tail leading off to the left, or the lower side. If you turn it sideways, you can see more easily, but up the stem plot, it's a little bit longer of a tail than on the lower portion. So the median test score is 82 points with an IQR of 13 points. The middle half of scores are between 76 and 89 points. Test scores have a range of 38 points with a high score of 96 points. Scores are skewed left, but there are no obvious outliers. So median test score is 82, that's my center. Spread, IQR of 13. IQR is a measure of spread. We go a little more detail by saying the middle half of scores are between 76 and 89 points. Mentioning the range is another measure of spread. Okay, scores are skewed left, that's the shape. And there's no obvious outliers, that's the unusual.